Hello everyone, welcome back. In the previous video, we discussed about the projectile motion from the top of a tower, which is projected upwards. In this case, we are going to discuss the same in the case of a body projected downwards. In here also, we are supposed to calculate the time taken by the body to reach the ground, height of the tower we will calculate, range of the projectile, and the velocity with which it will strike the ground and the angle with which it will be striking the ground. These are the terms that will be calculated here in this case of the downward projectile from the top of the tower. So for that, the diagram is shown in here where I'm taking the values of the values of velocity, be it or the acceleration, be it or the displacement, be it. I'm taking the values downward to be positive and towards the right to be to the positive x-axis is positive. And here in this direction, along the direction of motion, I take it as positive, and opposite to the direction of the motion, I take them as negative. Now, in this case, for the calculation of the time, the first one, we are supposed to calculate the time here. So for that time to calculate, what I use is, I use the equation using equation of motion, which is S is equal to ut plus half a t square. So it will be vertical motion, vertical displacement. So I will take it as Sy is equal to uy into t plus half into ay into t square. So I've already told you, whatever the terms that I take along the direction of motion, I take them to be positive. So Sy is the measurement that I make vertically downward, which is along the direction of motion. So I take it as positive. And y is what I measure again downward, so which will be taken to be here. If I take the components, uy is also downward, so uy is taken as u sine theta downward, which is positive. Ay is always acting downward, which is the gravity, so g value, and time t I replace it with capital T. So in this case, what I get is, I get an equation h is equal to u sine theta into capital T plus half g t square. So this is the height of the tower. You can write it simple way. You just can replace the height of the tower as h is equal to u sine theta into capital T plus half gt square. In most of the questions, the height of the tower will be provided, so need not to worry about it. The height of the tower is measured downward, so I took it positive anyway. Next thing that we are supposed to do is, we're supposed to calculate the time, right? So if you just get the equation in terms like this, what will you get is, I can rewrite the equation as gt square plus 2u sine theta into capital T minus 2h is equal to 0. On simplifying this, what I get the time period is, solving for time period capital T. What I get here is, I get the time period capital T is equal to, or the time, sorry, not time period, time T is equal to minus u sine theta divided by g plus r minus root over u square sine square theta by g square plus 2h by g under root. This will be the time that I get. And obviously we have to calculate the range also, which is the horizontal displacement. The component of velocity that is responsible for this horizontal displacement is the horizontal component of velocity. As horizontal component of velocity throughout the motion remains the constant, so what we can say is ax value again here is 0. So in that case, what I get here is, I get u cos theta into the total time taken for the particle to reach the ground from the top. Anyway, that will be the time in which it will have the vertical displacement of h and the horizontal displacement of r. These are calculated. Now the range is also known to us. So range r is equal to, the question B, range r is equal to ux into the total time. So r is equal to ux is u cos theta into t, where theta is the angle of projection. Now the last thing we are supposed to calculate is the velocity with which it will be striking the ground, and the particle striking the ground. So for that, I take a I use the equation of motion using vy square minus uy square is equal to 2 into ay into sy. So here uy is equal to u sine theta, which is measured to be positive. Ay is equal to, oh sorry, my mistake, one sec. Here the velocity at the point of striking the ground, I take it as v bar is equal to vx I cap plus vy j cap. So here we know very clearly that Vx, horizontal component of velocity, at any instant of time it will be always equal to Ux, which is u cos theta, and Vy is to be calculated. For this calculation of Vy, what I use is using equation of motion Vy square minus uy square is equal to 2 into ay into sy, from which I can calculate the value as uy value to be positive, so u sine theta downwards, it is positive. Ay is also downward, which is positive, and sy is also measured down along the direction of motion, so it is also to be taken positive. So for which I get vy square value, vy square minus u square sine square theta is equal to 2gh, and vy value will be equal to u square sine square theta plus 2gh under the root. So I know the vy value and I know the vx value, so the v, hence v bar is equal to, I can write it as u cos theta plus u cos theta into I cap plus root of u square sine square theta plus 2gh into j cap. So if I am supposed to calculate the magnitude of velocity here, so magnitude of this velocity is equal to v, I take it as a modulus of v bar, or I can get it also as v, from which I get it as root over vx square plus vy square, because these two are perpendicular components, so the cot theta value will become 0 cos 90 degrees, because if you have two vectors at a point and you have to calculate the resultant of the two vectors, you will have to calculate using the parallelogram law of vector addition, which is resultant of any two vectors is equal to p square plus q square plus 2pq cos theta. Here in this case I have the p as vx, q as vy, so it will be vx square plus vy square plus 2vx vy cos 90. 90 is 0, so it will be so much, so you will get it as u square cos square theta plus u square sine square theta plus 2gh, from which I get the value of velocity at the point of striking the ground as u square plus 2gh. So here why I get u square plus 2gh is because if I take the u square common out here in this equation, I get sine square theta plus cos square theta, which is 1. So now I have calculated the value of velocity at the point of striking the ground. Now what is the angle at which it strikes the ground? The angle which it strikes the ground, I have taken that angle as alpha. From the diagram, if you observe, so that alpha is here, so that alpha will be nothing other than tan alpha is equal to, I can write as opposite by adjacent. So I know the opposite value of velocity, I know the adjacent value of velocity, so I can write it as tan alpha is equal to vy by vx, where tan alpha can be written as vy value, I know it as u square sine square theta plus 2gh divided by vx value is u cos theta. So from which I can write alpha is equal to, tan inverse of root of u square sine square theta plus 2gh divided by u cos theta. So this is the angle with which it will be striking the ground, this is the angle with which it will strike the ground, this is the velocity with which it will strike the ground, and here we also have calculated the time taken by the particle to reach the ground, we have taken the range also to be calculated. Hope you understood the question. In the actual questions that you will get, they'll be providing you with the values, so that even the equations will get even more simple, like this time value will get even simple and you get the answer in an easy way. Hope you understood the solution. And we are now coming up after this we'll be uploading a video, next video, which is on the projectile motion, oblique projectile up the inclined plane we'll be uploading, and one more video will be also uploading, which is oblique projectile down the inclined plane. So I'll see you in the next video. Thank you.